Hiya guys, and welcome back to Wade's Workshop. I've been missing in action for a little while. I've been on holiday for a couple of weeks, and before that things were all a bit hectic with work and I was taking a bit of break from the workshop. Then the holiday came, that was 2 weeks out, and when I came back everything's a bit manic again. I've had a chest infection, all sorts, but anyway, I'm on the mend now. Right, so we're going to move on and make this part for the Stuart Models engine. We're going to make the crankshaft. No, we're not going to make the crankshaft, we're going to make the conrod. Not the piston rod, we made that last time. I think I inadvertently called it a conrod. That was the piston rod. This is the conrod. So basically in the kit they give you this piece of stock steel about 3.5 inches long, 3/8 by a quarter. Now it's on nominal before you even start, so it gives you very little or no margin for error when you're turning the tapered part in the centre. So I'll give you a little look at the drawing, and I'm going to actually make this part out of a bit of 12mm round stock, and we'll show you that on the lathe as we move forward. But let's go to the drawing. So this is the part here. Quick look at the drawing. This is part number 10. Okay, so there's a tapered turned area in the centre here, over 2 5/16 long, and it's 3/16 down here, 1/4 inch up here, and there's a fillet radius in either corner. I'm going to put about a 3mm radius in there. So we'll jump to the lathe and I'll show you how I'm going to do it on a piece of 12mm round stock, and then we're going to mill all the flats afterwards. I think it's just a simpler way of doing it, and it gives a bit more leeway in the setup. So I've decided not to use this piece of material. It's a piece of mild steel. I've got a piece of round bar, and I'll move my hand out of the way and show you where I am. So there's a piece of round bar here. It's 12mm diameter. It's a piece of foundium, material I've found, but I know it's tough stuff. So basically, drawing calls for a tapered turn diameter, 2 5/16 long, and tapering from 1/4 inch at this end to 3/16 at this end. That's going to mean swapping over and putting my compound back up. But I thought to start with, I'll probably bring you around the other side in a moment. I got for 2 1/4 long. I've got a radius on the end of my cutter. I will bring you around and show you this. And I'm going to take it down to a 1/4 plane diameter to the right lengths first. And the piece of high-speed steel I've got has got a radius on the end, about an 1/8 radius, something like that. It's probably about a 3mm radius, something like that on the end. I may just grind up a tool with a slightly smaller radius. It's hard to judge from the drawing, and the drawing doesn't really show it. So I'll bring you around the other side, and we'll carry on cutting this to a diameter of 1/4 inch. Parallel along the undercut in this round bar. Obviously we're going to machine the flats on later. Here's the cutter. So here's the cutter with a radius, as I said, and I'm machining up to that face there and finishing the left hand side as you see it. First of all, as you can see, the sides of the cutter itself are not parallel, so putting the radius onto an edge is tricky, but this just happens to be a tool I had lying around, but I can do that back edge. So yeah, we're a couple of thou off depth, so we'll get on that now. So yeah, just tickling along. That's a thou side cut, and I think we'll give it a measure after this. We're getting pretty close, within a thou or so now. So yeah, I'm watching through the viewfinder of the camera as to where I stop. In fact, I think my centre's come loose. Something's changed here. I'm getting close now. Knock off the feed there. I really am going to have to get on and do that feed on the end of the lathe. There we are, that's my 0 mark. I'll just come back off there. We'll switch that off. Yeah, I mean, this feed motor, yeah, I'm going to have to change it. I've got all the gear to do it. That'll be a future project, or a project coming up sooner rather than later. So we'll give this a measure. So it's purely a cosmetic detail, so where are we? Oh, let's come away from that radius. 255, okay, no problem. So I need a couple more flower side. try that. Some bead on. Off to go again. Bring you in a bit closer. Here we are. So I'm using the radius cutter to do the diameter, but I did rough it down to within, you know, a couple of hours where you saw me put this cutter up with a normal style cutter, one of my carbide tips. So just having a measure. Oh, that's blasting the camera out, bear with me. 2 5/16 I'm looking for. Hang on. I'm about a 64th short as we stand. So I'm going to take another 15th thou off that shoulder and call it. So I've just machined that. Let's just check. Looks like 2 5/16 to me, rule size between the two shoulders, and at a quarter diameter. So now I need to swap everything over, reset up, put my compound up, work out the angle, what a 16th drop is. No, a 32nd drop per side is over that length. And yeah, because we're reducing the diameter this end by a 16th, 3/16 this end, quarter that end. So I'll work out that angle, we'll put the compound up, set the compound, and we'll turn a taper in here. Okay, so I've set my compound up, just shy of 1 degree angle with the tail of the compound in towards the lathe. So I'll be cutting small end closer to the camera and the larger end at the back, so the cut will run out as I wind the compound along. I've set a tool up on center, the same tool with the radius, and if I just touch off from the beginning, I'll just set a 0 there, and as I wind forward the cut stops. I can wind back into that corner using the compound. Difficult for me to bring you around the other side. There. Another fell cut. Okay, so I spent a bit of time on it. The length is right to a rule. This is running about 185, this end, a couple of thou under, and this end, yeah, I mean, it's sort of 247, that sort of diameter. I've given it a little polish and I lost a thou either end, but yeah, I mean, that's pretty much the ornamental part. So having turned the taper in the shaft now, that end, this parallel piece that's going to be machined into a rectangle needs to be 1/2 inch long. So I think what I'm going to do is just part it off from this piece of stock, a little bit over length to start with. So I got the part tapped down on a parallel in the vise. The stock at present is 1/2 inch in diameter. Just bring the cutter down a little. So I want to reduce this thickness. I'll put 2 flats on, top and bottom, to reduce it to the 3/8, the larger size. So as we're starting off at 1/2 inch, we want 3/8, that's going to be a 16th off either side. So I think what I'll do is just do a little touch off, get somewhere central, about there, put my DRO in Imperial. Okay, let's just check that touch off. Yeah, just the slightest of touches. Just going to run a cut across there. So I'm going to want a 16th off either side. So 62.5 thou. Touching a little bit more there. It's a concern. Might have to just tap that down a little. And just stop that cutter. Yeah, it seems to be down. Let's just check that again. Something on the move here. I do not know what is going on. I may have something underneath my parallel. I'm just going to take that out again, because these both being the same sizes, that shouldn't be happening. So let me just double check we haven't got something sinister going on. Yeah, there's a piece of swarf under one end of the parallel. That answers that question. Make sure the parallel's central, yes it is. Nip the vise. Parallel's clamped. Let me just come off a couple of thou and see if I can get a uniform touch off on here. Okay, let's see what we've got the other end. Not touching this time, that's more like it. Just scratching there. Let's go back the other way. Should take a touch the other end as well. And the flats, the two flats I can see on here should look identical, and they do. So okay, I know I've got it down flush in the vise this time. Right, okay, you just got to keep an eye on these things sometimes. That's saying I've taken 6, I'm going to take another 10 thou. So I'm going to keep taking this down. I'll put a mic on the ends, either end, probably both ends, until I get to, what am I looking for? 7/16. Then I'll flip it over and do the other side, parallel to this side, until I get to the 3/8. So I'm looking for 7/16, 437.5 thou. 450, 468.5. So that'll be 31 thou to come off. So I'll just set a 0 on my quill, and my measurement's going to be 31 thou. So I think I'll take 3/10 thou cuts. So just at a measure, we got a half thou difference length end to end, but I have got a little bit of a burr on the underside of here. That might have been why it wasn't sitting down properly when I did it the first time. So we can take it out the vise now. I'm going to give it all a nice little clean out in there, because we don't want to do what we did last time. parallel centre about. Just check for some burrs on here. Now we're all right. Oh, a little one there, but it should be out of the problem area. Just hold it down on that parallel while I nip the vise. Make sure that the flats are aligned on top of the parallel. Yeah, looks good. Okay, so in theory I'm going to come off maybe 3 thou, just run a cut across there. Shouldn't be touching anywhere, just to make sure we haven't done something daft again. Maybe that little burr on the end. No, not touching. Please don't touch on the other end, so I know it's down. Yeah, we're okay. Just come down that 3 thou. That should be about 0 there. Should get the same touch on the other end. Yeah, just the lightest of touches. Okay. So let's put a 10 thou cut on. And we'll have a measure up, see what's left. So I've been taking a 10 thou cut. What we got? 424. So 49 thou to come off. I'll just set a 0 again. I'll take a series of 10 thou cuts. I'll take 40 and we'll have another check. So it showed 9 thou left to come off. I've just taken, where are we? 7. And that should leave about 2 thou left on for a finishing cut. Let's just come back out the way. Just turn that cutter off. Okay. A little bit of swarf. Two thou. 377. Make sure we haven't got any taper in here. Yeah, it's showing 2 thou everywhere. Okay, so let's just bring 2 thou on a DRO. Come down. There we go. 2 thou. Just have a little bit of liquid love on there. Hang on, spread that out a bit. Okay. And take it down to size. So rotate it 90 degrees. Hold on those 2 flats that we just machined. So the largest end on this is 1/4 of an inch overall, which is pretty much the size of the end of the shaft there. So what I'm going to do is machine the whole thing to 1/4 and then do the reduction on this end afterwards. So that's where we are with that. So let's just come way back up out of the way. Hold on. Tappy tappy, eh? Oop. We're down. come down for a touch. There we go. Should have something similar this end. Just touching it. Okay, so I think I'll take 10 thou. This being 1/2 inch at the moment, and the finished size when I've done both sides being 1/4, that means there's an 1/8 to come off either side. So I need to finish this dimension to 3/8. So it's flipped round the other way. I had to mess about with the parallels a bit to get the height to stick up. Well, just under 1 thou oversized, so I'm just dialing that thou. That should do me. Step over that little bit. And that should be it. 3/8 by 1/4 along the full length. Now this end, the small end of the taper, has to be 3/16 wide. So I've got extra material on the end of here, quite a bit of extra material, probably about, I don't know, 3/16 extra. So what I'm going to do is reduce this now to the 3/16, but not across the full length, only as much as is needed. And that means when I turn it over, it'll still sit on the 1/4 size pieces for me to do the same on the other side and reduce the material down to the right size, but leaving the high point on the end. I'll show you that as I do it. It'll become more clear maybe. It just makes it easier to hold while I'm doing it. I mean, this side I could just machine it off. It's when I flip it back over the other way to do the same on the other side that this little bit on the end of the right size is going to help me. So let me just check that I reach my target. Well, yeah, 250, 249, 6 maybe. Yeah, okay. So, yeah, happy enough for what that's doing. So the length of the square end when it's finished is 5/16. So what I've done is I've stepped the cutter over 3/8 of an inch. And I'm going to reduce the thickness of this to the 3/16. Oh, well, I'm going to take a 32nd off either side, reducing the 1/4 it is now to 3/16. But not over the full length, so that this area, unmachined area, will still sit on the parallel when I flip it over. So I'm on a 0 datum there. What do I need to take off a 32nd, which is, yeah, 31 thou. So let's do, I don't know, 10 thou first. And 20, just feeding down with a quill. That's 29. That's reading 31. Okay, I think I've got a little piece, yeah, there's a little piece of the radius still sitting there. I think I need to just step over a little bit. Let's just run that cut across again. Nothing I can't sort out with a needle file afterwards. Okay, so I'm going to leave that setting, that reading, exactly where it is. And I'm going to set it up the other way. I'll do this on camera. I think, am I still in shot? Yes, just about. So I'm just going to flip this. May have to just take a little deburr on there. Apologies, I'm just off shot here. Just deburring the edge that I've just machined. Okay, so I'm going to flip it around that way now, upside down to where it just was. To be careful when tapping this down. Lift the vise up. And on the end. Okay. I'm just going to wind back to my 0. Establish that size again. Oh, let's catch it. My lock handle. Okay, that's a bow on the edge. Let's move across 3/8. 375 on the DRO, lock the X, come back off, see where I touch, should be 0. Anywhere around here. Half thou out. Okay, so 31 thou again. There's 10. 20. I'll probably do about 31.5 this time. There. Step back across. A little bit more. Okay. Come out the way. Just have a look at that. That's good. Make sure I've caught all of that radius. Damn it. Okay, so that's dimensionally the 3/16 by 3/8 square on this end and the 3/8 by 1/4 square on this end. Now I need to just cut the ends to length, and there's going to be a radius on either end and 2 holes to drill. Let's just see how I did. So that there wants to be 1875. Where are we? 125, 135, no, 175, 185, 186, 187, 188. 187. Yeah, I mean it's within a thou. Yeah, happy with that. So 1/4 by 3/8, 3/16 by 3/8. Just got to do a bit of deburring. Now I need to machine the ends to the finished length. There's not much on this one, but there's a fair bit on this one. I think what I'm going to do is, while I've got it easy to hold in this plane, because I've still got this 1/4 bit on the end, I'm going to drill the 2 holes. So I think that's the next job. So this being the thick end, this length of this square part, it's got to be 1/2 inch. So you can see there's a bit left on. By eye, it's about a 1/16. So let's take 30 thou off it. I've got a 0 on my DRO. There's 14. $25. That's 30. Should be about a 32nd now. Yeah, another 30 thou. That's 40. $50. $55, and that's the 60 thou off the end. Okay, that gives me a reference point for the holes, because gives me a known position lengthwise. Let's just double check. In fact, I reckon there's another 3 or 4 thou on there. 64. I reckon we got it 1/2 inch. Certainly as close as the rule in the eye will show, which is, you know, probably in the 5 thou range, maybe closer on a good day. Right, so I want 2 holes in here. I'm going to have to pop the parallel out. It's all going to be a bit dodgy. Yeah, I can slip the parallel back that way. This is in clearance, but it's not, if that makes sense. This end's going to be a bit dodgy to do. Wondering the best way to do this, to hold it to do it. I think I can tap the parallel back in there, I believe. Out the way I can. I could probably do the same the other way, but get most of the way through the hole before I tap the parallel out the way, I think is the secret with that. So I'm going to set up drill chuck edge finder. Well, let's get edge finder on there first. We'll pick up the center, we'll pick up the end, and we'll drill the first hole. So first hole, I picked up the center, I picked up the end of both sides with a wiggler, center found it, and I've come in the 3/16, and hole number 1. Just center drill the hole. Now this hole is in the large end. There is a feature in this. I'm going to have to see if I got the right cutter for it at some point. Okay, so that's center drilled. Let's set X at 0. Y is already at 0. Okay, so the centers of the 2 holes, according to the drawing, are 2 and 13/16. So let's use the feed, come across to 2 and 13/16. Which is 2.8125. Okay, 2.8125. Okay. I think this is a much smaller hole. I'm just going to put a little divot in there with a center drill. I think I'm not going to use it. I think the center drill might be a bit big. Got a feeling that's a 3/32 hole. Let's have a quick look at the drawing while I'm on this spot. 3/32, so I need to get a 3/32 reamer. Oh, we're a bit out of focus there, guys. So I've just got some bits together. Right, I'm going to go back to my 0. I'm going to do this end first. So this is 3/16. So I'm going to ream it 3/16. So I've got a 4.6 drill, or I will have very shortly. Let's just go up a bit. Let's come back to 0. 0 is... somebody's decided they're going to do a bit of strimming or pressure washing outside somewhere. Just to make a racket for me. Come on. Right. 4.6 drill. Straight through. A little bit of liquid. Right, I've pushed the parallel back out of the way, so I'm not going to be drilling into the parallel. A little bit more juice on there. Okay. And nice shiny new 3/16 reamer. Let's slow her down. A little bit of liquid. Okay. So that's that hole done. I think I'll just get a little countersink while I'm here. Just put a little break edge on that hole and then pop the reamer back in again. Might have to do the same on the other side. Oop. A bit. Just a little countersink. Just pop the reamer back in. That'll do. Make sure I haven't rounded the hole in any way or burred it over. Okay, so back to this size now. 2.8125. Whoop. Okay, so I got the drill at the ready. That's a little slow for that drill. Let's come down a touch. Okay, I wonder if I can just get that parallel out of the way. I can. Right, gently, gently. Okay. Pilot drill for the reamer. Then a 3/32 reamer. that. And there we are. That's the 2 holes in the correct place. There's one more little detail on here. There's a counterbore in here, flat bottom counterbore, a 16th deep, and the drawing calls for 17/64 diameter. Now, I haven't got a cutter, 17/64 or a flat bottom set drill, anything like that. The closest I've got is a 7mm cutter. So I can get the depth right, and I can do 7mm. Now, it's actually clearance on a quarter, a little quarter bolt, a little shouldered bolt that goes in there, and it's clearance on that shouldered bolt. There's no reason why I can't make that little shouldered bolt a little bit bigger to keep the sort of clearances correct, and in fact it'll give it a bigger flange area. So I'm going to do it 7mm. So basically what I'm going to do is just bring that cutter down to touch, set a 0 on my quill. There we are. Just lock that off. And I need to go a 16th deep from touch off from that 0. Just check my drawing. Yes, a 16th deep, but it was 17/64. 17/64 works out at about, let's have a look, 17/64? Yes. Just over a quarter, I believe. It's about 6.75 mil. So yeah, I'm not that much bigger. 275, 265. I'm 10 thou oversize, so no great problems here. So I'm going to use the fine feed. Might put a little bit of loop on there, and I want to go a 16th deep, which is 62.5 thou. Touch, and I'm on 0. Good. It's 50. Okay. So it was a waste of time putting that little chamfer on there earlier, wasn't it? There we are. Now, that's going to leave a wall thickness. There's a little shouldered bolt going to go in there, and it needs to stick out the other side when it clamps onto, it's actually onto the crankshaft. The little shouldered bolt will need a little bit proud sticking out. So when I make the shouldered bolt, it'll be made to suit this part, almost making it to fit. So anyway, that's that little bit done. So I need to machine the ends to size now. So the other end is already done. I'm hoping that this centre drill will disappear that we used earlier on when we turned it. Worked out the overall length. It should be easy enough to work out. But because one end is finished, I can either do it with a rule or calipers would do, I suppose, for this. So I'm going to have to look at the drawing in a minute and see what length it should be. 3 or 4 mil to come off yet. So this is the bit on the end that was left at the quarter thickness is all being removed. It's nearly all gone now. And as you can see, the little centre drill that was in the end has now disappeared. Well, that's good news. Okay, so let me go to the drawing, see what the overall length is supposed to be, and we can have a measure. So I did a little working out, and the overall length is 3 1/8. So I just went into my toolboxes for a 3 to 4 mic, and you know, I haven't got one. So we won't be using a mic. It'll have to be done with the calipers. I'm going to start browsing eBay for a 3 to 4 mic. So I do have a 75 to 100. Do I? No, I don't even have one of those. So that's two mics I'm going to be looking at. I'm good up to 3" and I'm good up to 75mm. So I'm going to have an eBay look. So if anyone's thinking of buying one on eBay, don't, because you'll be competing against me. Right, okay. 3.131, so 6 thou. Just set a 0 on my X. And there's 6 thou left on me. I did have a look with a rule earlier. Left it just a tad up. I thought I'll leave it a tad up and then get the mic out. Of course that didn't happen. I think not one. Yeah, it's one of those things, you know, I'm not going to spend a fortune on it. How often will I use it? Who knows, but still. 3.1265. Thou and a half. Okay. That's it, finishing cut. 3.125. Always like to check and see what we hit in the end. Well, sad, it just moved a little bit. 3.1255, but it's actually yeah, it is 3.125. Okay, happy days with that. So the only job left on this part now is a radius on the end there. I think it's 3/16 radius, and the same on the other end. Is it 3/16 both ends? Yep, 3/16 rad both ends. How am I going to go about that? This end's tricky because the hole isn't on centre of the rad. This end's easy because the hole is on centre. Yeah, we'll have a think about this one. This one I can think of several ways of doing it, but this one's tricky. So many of you will have seen me do this sort of technique before. I've turned up a little shaft with a little 3/8 step on it, which is the 3/16 radius, and a 3/16 spigot on it. Let me just turn that cutter off, see if I can show you the little fixture. Let me just pop it off. Yeah, 3/8 here and a 3/16 spigot, which fits into the part, into that hole, which is around the centre of the rad. Problem with the one on the other end, it isn't. So just placing that down on there, keep it square. Right, let me just start that cutter up again. So yeah, using a 180 degree plane or slightly less, only cutting in the conventional milling direction. So I'll put the cut on here and rotate the part around in the cutter, taking care not to go beyond the 180. So as you can imagine, if I came around this way, I'll cut into the part where I don't want the machine. Put a cut on. So I'm putting a cut on by moving the table, or the pin, as it were, towards the cutter. We're getting close now. And I turned this pin to be a good fit in the hole. Well, another plough is that it's almost at 90 degrees and it's still cutting. call that. And there we are. As you can see, there's the radius on the end at the 3/16. Happy days. That one was really simple. Bit of deburring on that end now, and that's that end complete. And I think I'm going to have to go for the old school method on this one and file this by hand, I think. So about 10 minutes work with a file, just dressing that radius on the end. It looks a bit weird because that hole's not concentric to the radius. But yeah, basically filed it and set a rad gauge on it, and yeah, we're pretty much spot on. So yeah, only sort of variation from the drawing is that counterbore is 7mm diameter instead of the was it 1764s on the drawing, something like that. And obviously I didn't use the raw material that they gave us. I used a piece of, as it turned out, 1/2" round bar. It was tough stuff, probably 01 and a little bit tougher maybe. I don't know exactly what it was. As I say, it was a bit of foundium. So yeah, happy days with that. Well, here we are, guys. Nice long video this one, but I think that's about enough. That's the conrod complete. It was a fiddly little job, a lot of details in it and sort of difficult to hold and all, but I think that using the round bar that I used was probably simpler than trying to set up the stock bar that was supplied. So yeah, I mean, if I was to do it again, I think I'd probably try it with a stock bar, but if all else fails, you can always do it the way I did it. Right, okay. So, thanks for watching, guys. Thanks for subscribing, and we'll see you all very soon. Cheers now.